So, Whifters, this is Prof. G, and in this video we're going to use some Swifty string instruments, that is, methods and properties and other techniques, to become virtuosos of string manipulation. The ability to work with strings is one of the most important skills in programming. We often want to compare and manipulate text, so in this lesson we're going to pull up a playground, and even though the work that we'll do will be directly related to our WordGarden app, this video can also be viewed as a standalone lesson on working with strings. We're going to cover a bunch of techniques that you'll definitely want in your Swifty repertoire. We're going to learn how to search inside strings with contains, hasPrefix, and hasSuffix. We're going to learn to alter strings with removeFirst, removeLast, and replacing occurrences of with. We're going to learn to get capitalization just right with uppercase, lowercase, and capitalized. We're going to learn to iterate through strings. We'll create a string using a repeated value, and we'll also have a couple of challenges, the results of which we will use in the WordGarden app in a subsequent video. Swifters, I don't want to string you along any further. Let's code! If you're new here, welcome. You might want to check out the course playlist to see how we got here. So why don't you open up an Xcode playground? I've saved mine as string work. Let's code. And the first thing I'm going to show you is the contains method, which checks to see if a string contains another string. Now I'll check to see if my last name contains the word laugh. It does. It's an unusual spelling of Gallagher, or as the Irish pronounce it, Gallagher. But if you'll kindly indulge me, we'll use this as a feature, not a bug, to demonstrate how the contains method works. Now I'll create a variable, my name, equal to Gallagher, capital G, lowercase A-L-L-A-U-G-H-E-R. And on the next line, we'll create the string we're searching for within my name. So I'll write var, smaller string, equals, and that'll be the string laugh, all in lowercase, L-A-U-G-H. Then on the next line, we'll say if my name, and if I start to type dot contains, code completion says this returns a Boolean value, meaning true or false, indicating whether the collection, and remember a string is a collection, contains the given regex. What's a regex? Don't worry about it for now. Really, any string or character you pass in will work, so we'll see if that's contained in the outermost string, the my name string. If you're curious or you have experience with other programming languages, regex stands for regular expression. It's a standard for searching, matching, and manipulating patterns in strings. We won't talk about them now. The code for regex isn't very intuitive, and we don't need it. But we can see that there's more here because there's a right-pointing chevron. Now, we learned in prior lessons that if you press the right arrow key, you'll expose all the different versions of the statement that are available. All of these do the same thing. They all return true or false depending on whether the expression is inside of the string. Now, even though these all work with different types, character, string, substring, and we can go down here and select the one for string since we're going to be passing a string in to see if it's contained inside of my name, the argument label for the parameter doesn't change. In fact, there isn't one. All of these have just an underscore, meaning there's no argument label. That means all we need are parentheses after contains, and you can put a string or a character inside. So press return, then in between the parentheses, we'll pass in smaller string. Open and close curlies. Inside this, I'm going to say print string interp contains string interp. My name contains smaller string. Else, open and close curlies, print there is no string interp in string interp, and that'll be there's no smaller string in my name. Shift return. Gallagher contains laugh. Hopefully you like my jokes and think this is a positive. Let me know in the comments if you do. Otherwise, if you don't like the jokes and puns, well, we'll just move on. By the way, contains doesn't only work on strings, it works on other collections like arrays. So if you want to see if an array contains an element, you could use contains there as well. And just to test other conditions, there was this terrible comic back in the 70s and 80s. He smashes watermelons. His name was Gallagher without the U. That's the way most Gallaghers spell their name. So let's remove the U from my name, shift return to run the code. It says there's no laugh in Gallagher without the U, spelled like the watermelon guy, which is probably right. That watermelon thing wasn't really all that funny. You can look it up on YouTube if you want. I don't recommend it. But things are looking sunny for you, though, because you now know how to use the contains method. And to mark these in my notes, I'll put a comment up here that says contains, and in the selection below, we're going to show hasPrefix and hasSuffix, so I'll put a comment there too. And we'll demonstrate these methods by searching for a substring in an occupation name. So we'll say var occupation equals the string Swift developer, and below that we'll say var search string equals Swift. Then to see what the hasPrefix method does, on the next line we'll enter print, and in parentheses, occupation.hasPrefix. And for some reason, hasPrefix has no description in code completion, but we see it returns a bool, so it's pretty self-explanatory. So we'll press return, accept this, and between the parens, we'll pass in search string, then shift return. And since we get a bool value, we see that this simply prints out true. That's because the occupation, Swift developer, has the prefix search string, which is Swift. We can say if occupation.hasPrefix, passing in search string, open and close curlies, and inside we can say print you're hired. Else, in between curlies, we can say print no job for you. pressing return, we see that we get "you're hired" because the search string is Swift and the occupation is Swift developer. May you have similar success in your career. But if we change the occupation from Swift developer to real estate developer, shift return, no job for you. And to make this clear in our notes, I'm going to get rid of that first print statement that printed the Boolean value, and instead I'll say print \n prefix search. And then I'll copy and paste this set of code here, paste it down below, and this is where we're going to work on a suffix, so I'll change it to print suffix search, and inside I'll say if occupation has suffix search string. And above this, why don't we update the occupation and search string so that it works well with the hasSuffix. We'll say occupation equals iOS developer and search string equals developer. And why don't we modify these print statements? So if it's true, we'll say we need more string interps occupation. And below that, we'll say no job for you, no one needs any string interps occupation. Then we'll shift return. We need more iOS developers. Outstanding. But if we change occupation from iOS developer to iOS hater, no job for you. No one needs any iOS haters. Now on to our next example. We'll put in a comment saying this is .removeLast, and we'll put in a print statement with the escaping character \n remove. And for this example, let's go to the world of rock and roll. So we'll say var band name equals the White Stripes, and then we'll imagine Jack White wants to go out on his own. So we'll say let lastChar equals band name .removeLast. Code completion says this removes and returns the last element of a collection. Now it knows it's operating on a string, so it's going to return a character. However, because it says it does work on collections, you could use this on arrays or other collection types. Now this modifies the original string, which is important because you can't call this on a constant because it's going to modify that original string. Now even though this returns a character, it's also okay to ignore that return value if you don't need the return value. That's what we're going to do here because we don't really care about the character at the end. We just want to modify the string that we call removeLast on. So we'll press return here, and below this we'll put in a print statement. After we remove string interp lastChar, the band name is just string interp band name. Shift return. And after we shift return, we see down below the console says, after we remove S, the band is just the White Stripe. That's the removeLast method in action. So if we've got to remove last, what about removeFirst? Let's enter a comment, .removeFirst, and we'll print the escaping character \n removeFirst. And you know what? removeFirst works just like removeLast, so why don't we use a different option in here? We'll say in the comment removeFirst, and then in parentheses I'll say k:'int. This is going to remove the first k characters, and in the print statement we'll just say removeFirst $. And oh, as our example, why don't we revoke the license of the worst doctor in the history of cartoondom? I'm speaking, of course, of Dr. Nick from The Simpsons. So in the next line, var person equals, and in quotes, Dr. Nick, and below that we'll say let title equals the string doctor, entered just as the title above it. And we'll write this so we can remove any title from any person's string. So we'll say person.removeF, and we see removeFirst has two options in here. Use the arrow key to select the option that has the k: in there. Code completion says this removes the specified number of elements from the beginning of the collection. That's the beginning of the string in this case. Of course, since it says collection, you could remove the first k elements of an array if you would like. So press return to accept this, and if we want to remove any title that we'd pass in here, we could say title.count. Now this result is not quite optimal. Let's see if you can catch why. Let's say print person down below, and we see, oh yeah, we've got space Nick. How come? Well, when we removed title.count, we didn't remove the single space that's in between Doctor and Nick, and instead we can just modify the removeFirst statement, so we're going to remove the first title.count +1. Shift return, and there we see we've taken away Dr. Nick's license. He is now just Nick. And now let's put in a comment for the next method we're going to try out. That's .replacingOccuranes, and in parentheses it's of, with, and then on the next line we'll say print \n replacingOccuranes of. Now this is a super useful method, especially when it comes to data cleaning, because remember, you could have multiple strings that refer to the same thing but that are spelled slightly differently. And a lot of times when you work with data analytics, data mining, machine learning, you may have data that comes from different sources and it might have been recorded with different standards. And to show this, I'll put an example in the comments. We'll have 3 different street addresses for the very same street. The first one uses the ST dot abbreviation, the second one is just ST, and the last one is the full word street. So a human being looks at those 3 addresses and says they're the same thing. A computer looks at those 3 addresses and sees 3 different things. You want to use this in computing, then you got to clean it up. And if you want to clean up your data, replacing occurrences of with is a great method to use. And so why don't we try this out? We'll say var address equals, and in double quotes, pass in this first option, 123 James Street, that's capital S, lowercase t, period. And then we'll create a variable of the value that we want to find to replace. So we'll say var street string equals, and we'll pass in the string just as we see it above, capital S, lowercase t, period. So we'll consider the abbreviation st period like this to be dirty data. What do we want to replace it with? We'll create a variable for that too. Var replacement string equals, and here we'll use the full name street, capital S, lowercase treet. So we'll put our revised address into a variable var standard address, and we'll set this equal to address, our initial address, dot, and as I start to type in replacing, we've got lots of different options in here, but we want the option that says replacing occurrences of with, so select that. And code completion says this is going to return a new string with all occurrences of the target string in the specified range of the string replaced with another given string. In other words, it'll look for all occurrences of the string you pass in after of, and it'll replace that with the string you pass in after with. So press return to accept this, and for the of option, we're going to replace occurrences of street string with replacement string. Then we'll print out, how about standard address, comma address, shift return, and down below, we see the new modified standard address is 123 James Street with the full word street in there, and the original address was 123 James St period with the abbreviation. So we replaced the string, standardized it on the full word street. Nice. Now here's a challenge to think about. I'm not going to show you the answer to this one, but as a comment I'll put in a challenge for you to try out. What would you do if we had 123 St. James Street, so that we have an abbreviation for St. St period, and we have the abbreviation for street St period? Haha. Maybe we'll present this in class, and if you're not in class, I'm sure you can figure it out on your own. And next up, I'll put in a comment that says we're about to iterate through a string, and we'll put in a print statement with \n that says we're going to iterate through backwards string, or go through a string backwards letter by letter. Now, before we iterate through a string backwards, let's do it forward. And you can use a name. Why don't we say var name equals, put your own name in if you'd like. I'm going to use my name, Gallagher. And then we iterate through a string the same way we'd iterate through an array. So we can say for letter in name, open and close curlies, print letter. Then down below, we see each letter prints out in a separate line. Well, how about a challenge? Can you print your name on a single line, but with all the letters backwards? Pause. Give it a try. Resume when you're ready, and let's take a look at one answer. Now, one thing to remember, if we option click on letter is going to be a character, not a string. Now, why don't we build up the string each time we go through the for loop one letter at a time? So we'll call this end result that we're going to be building up backwards name, but it should initially start out empty. So just above the for loop, we'll say var backwards name equals empty string. So we're going to start out, there's nothing in backwards name, but we're going to create that inside the for loop. And inside that loop, we'll say backwards name equals letter plus backward name. But oh yeah, that's not going to work out because we can't add a character to a string. No biggie. You know many ways to fix this. One way is to simply put the word capital string in front of the constant letter and wrap that constant in parentheses. Then down below, why don't we print out string interp, comma, string interp. In the first string interp, we'll put name, and in the second one, we'll put backwards name. Let's run this with a shift return, and we get Gallagher, and then Gallagher backwards. Nice. Now, some of you might have remembered that we learned about the reversed method, so you might have thought you could try it here. Settings, for example, backwards name equals to name.reversed with parentheses, but unfortunately, this doesn't work on strings. We eventually get an error in code completion. No reversed candidates produce the expected contextual result type string. That just means the result of name.reversed is not a type string. Now, there are a couple of ways we can get around this, one using a loop and the other by converting a result to a string. Let me show you them both. I'm going to highlight this code from backwards name equals empty string. I don't need the var in here because I've already declared this, and I've highlighted through print name comma backwards name. So copy this, then I can highlight this backwards name, the print line that don't work, and I'll paste what I just copied over these two errant lines. And here in my for loop, I can iterate on name.reversed, so that will start at my last letter and go to the beginning letter. So even though I can't assign name.reversed to a string or even print this out and have it look like the reversed name, I can say name.reversed, and that'll iterate on the string as if it's iterating on a reversed array, last letter to first letter. Then I can change the line inside the curly so it reads backwards name equals backwards name plus string letter, or I could use the simplified notation backwards name plus equals string letter. Then shift return down below, and we get Gallagher, comma, backwards Gallagher. And I have a little bit of print pollution down here, but if I click stop and the play button again, I can see, yep, it's working fine. Now it is possible to use that .reversed method, and it's worth showing this because we can also point out why it can be useful to pay attention to code completion. So let's create a new variable, var new backwards name. We'll set this equal to name dot and start to type reversed. Now look at code completion. This says it returns a reversed collection of a string. So it's not a string value. So you might wonder, I wonder what this looks like when it's printed. Let's try that out. No harm here. Print name, comma, new backwards name. And it says Gallagher space reverse collection string base Gallagher. That is not at all friendly. But if this is a different type, we do know how we can convert other types into a string. I wonder if that'll work here. Well, you know how to do that. You can just go up here to name.reverse. This is the thing that gives us the reverse collection string base Gallagher. Put parentheses around it, put string out front of it. Now shift return and run, and hey, this works. No loop required, very efficient. Nice. So paying attention to the output, the type that you're getting back, allowed us to think about, could we convert this to a string? We in fact could. So I hope it was useful showing you a few different ways we could solve that challenge. Next up, we're going to work with capitalization. So I'll put in a comment that says capitalization and a print statement \n that says playing with caps. Now capitalization is really important in working with strings, especially when you're comparing strings, because capitalization matters when comparing strings, and a string with uppercase letters is different from a string with lowercase letters. Then to test this out, I'm going to create a variable in the next line, var crazy caps equals, and I'll say Swift developer, but I'll randomly include either uppercase or lowercase letters. Then below this, I'm going to create a variable var uppercased, set that equal to crazy caps dot uppercased. This is a method. We can tell by the M and the two parentheses afterward. It doesn't accept any variable, but it returns a string, which is an uppercased version of the string. Press return to accept this. Well, if there's an uppercase, is there a lowercase? Yes, there is. So in the next line, we'll say var lowercase equals crazycaps dot lowercase. We can see in code completion, it returns a lowercase version of the string. Press return to accept this. And there's one more way that we can work with caps. We'll say var capitalized equals crazycaps dot capitalized. And capitalized says that this is a copy of a string with each word changed to its corresponding capitalized spelling. Now, curiously, you see the P up here. That means it's a property. It's actually a calculated value. And so we just refer to the property name. We don't put parentheses afterward. The other two options we used, uppercase and lowercase, were both methods. Now, methods are functions on a type, and functions, as we know, need to have parentheses. That's why we have parentheses after uppercase and lowercase. No, I'm not sure why the geniuses in Apple decided that uppercase and lowercase need to be methods, but capitalized should be a computed property. I'm sure they've got their reasons. I suppose I should ask one of my former students who's a lead on the SwiftUI team. But regardless, Xcode would go ahead and insert parentheses if we need them. We don't need them here, so press return to accept this. Then on the next line, why don't we print crazy caps, and below that we'll print uppercase, comma lowercase, comma capitalized. Shift return to run this code. And in the console, we see the crazy cap Swift developer, but below that, we see Swift developer in all caps, in all lowercase, and then just with the capital letters in front of Swift and developer. And just to show you that crazy caps hasn't been changed, I'm going to copy the line for print crazy caps, put that down below, shift return, enter this code again, and we see, yep, crazy caps was not changed. Nice. And very handy. So now let's use what we've learned about strings and iterating through strings for another challenge, and we'll leverage the solution to this challenge in the WordGarden app in our next video. So in our WordGarden app, a word that the user is challenged to guess will show up in a revealed word variable as underscores with spaces between the letters. So for example, if the word to guess is Swift, S-W-I-F-T, then the revealed word should be 5 underscores separated by spaces. Now assume that the word the user will be guessing is held in a variable named word to guess, and write a routine that will return a value revealed word that contains an underscore for every letter and word to guess with a space between each underscore. Now you can do this right in the playground. You don't even have to create it as a function. Why don't you pause here, give this a shot, resume when you've given this a try, and I'll show you a couple of working solutions. So I'll first enter a comment, word to guess challenge, and print \n word to guess, then create a variable word to guess equals, in quote, Swift, all caps, and then I'll create a variable revealed word and initially set this equal to the empty string. And now let's iterate through word to guess. For letter in word to guess, open and close curlies, and there are a few ways we could do this. Why don't we start out by saying revealed word equals revealed word plus, and then the string, the underscore character, and a single space. Now this is almost what we want. Why don't we print out string interp word to guess will show as string interp revealed word, and I've got quotes around my second string interp. And if I shift enter below, this looks good, but there's an extra space at the end of the word to guess. Well, we know how to get rid of the extra space at the end of a string. Now, some of you might have noticed that we don't need the letter value in our loop, so we can actually get rid of this unused constant since it's not used. We can replace it with an underscore. This isn't necessary. Our code won't crash with an unused value in here, but it's a nice thing to do as a developer, so someone looking at your code doesn't wonder, what's going on with that letter? I don't see it anyplace. Then I'll go just above the print statement and I'll say revealed word dot remove last, open and close parens. I didn't need to print this out. It's just going to print out a blank space, so it's going to look like a new line. And if I shift return below to execute all of my code, I can see I've now got 5 underscores separated by 4 spaces. Perfect. Now here's another solution where we don't even need this line with removeLast. So I'm going to delete this line, and I'm going to change the string that I add to revealed word to, instead of underscore space, now it'll be space underscore. And we're going to start out with the revealed word not equal to an empty string, but equal to an underscore. Now this almost works, but this is going to give us one more space underscore than we need. But instead of iterating on word to guess, what we'll do instead is we'll iterate on a range, and we'll do one character less than the length of word to guess since we start out with that underscore. So let's replace word to guess with 1 ... word to guess count -1. Now this is going to work assuming that any word to guess is at least 2 letters, and I think that that's a fair assumption. If we had something that was less than 2 letters, then we wouldn't get a valid range to work with. So now let's go ahead and shift return down below, and this works great too. Same answer. Now I'm going to show you one more super efficient method that doesn't involve using loops at all. It involves using a technique to create a string based on a repeating value. So I'm going to enter a comment below that says create a string from a repeating value, and we'll print \n string from a repeating value. And we'll say here revealed word equals, and we'll start this with a string which is just simply 1 underscore, since every revealed word is going to start with an underscore. And then we'll say plus, and then we'll give the type of data that we're creating, which is a string, capital S. And you see what this reveals in the code completion? It's a bunch of different ways that we can create strings, and there are a whole bunch in here. These are sometimes called initializers, since we're initializing a new string. And we can scroll down here. These are alphabetized, and I want to find the option for repeating count. And here it is. We see that there's a right pointing chevron in here. So if you type the right arrow on your keyboard, you'll expose a few options. It doesn't matter which version we select, Xcode will use the right one based on whether or not we pass in a string or a character. If we highlight this, code completion says that this takes a string and a count, which is an integer, and the description says it creates a new string representing the given string repeated the specified number of times. In other words, this is going to create a string that's the string that we pass in, repeated count number of times. That's what we want. So press return to accept this, and for repeating, we're going to put in between quotes, space, underscore, and for count we'll just say word to guess count -1, and below this we'll simply say print, and in parentheses revealed word. Shift return, and will you look at that? Same result, but this time it took us only 1 line of code to get there. Super slick. And now we've got our final challenge, the revealed word after last guess challenge. And we'll use the code that we're about to write in our WordGarden app as well, but first we'll solve the challenge in the playground. I'll show the solution in the next lesson and also introduce the map function, which will help us write super efficient code, and then we'll be ready to add the code to WordGarden. So in our WordGarden app, as the user guesses a letter, we will eventually add the guessed letter to a string named letters guessed. Now what I want you to do is to write a routine, it doesn't have to be a function, that'll go through all of the letters in the variable word to guess, checking to see if that letter in word to guess has been guessed. Hint, you're going to check to see if the letter in word to guess is in letters guessed. And if it is, reveal the letter. If not, show an underscore and add a space between the letter or the underscore. And that result should be inside of a variable named revealed word. Now as an example, the image at the right shows the revealed word, that's this string here, if the user had guessed the letters S, Q, F, T, and X. In other words, if we pass in letters guessed equals S, Q, F, T, X, and word to guess equals Swift, all uppercase letters, then your code should show revealed word as the string S__FT with spaces between the letters and the underscores. So why don't you give this a shot? You can apply the vast learning that you acquired in this and other lessons, and in the next lesson, I'll show you a few solutions, including one that introduces the map function. Until then, continue to hack.